Now let us discuss about the overturning effect. Now this centrifugal force that tends the vehicle to overturn about the outer wheels, in this figure this is the outer wheels B on horizontal curve without super elevation is illustrated in this figure. Okay, now the overturning moment due to the centrifugal force P is P into H. So how you calculate it? That is the CG, and CG is at a height of H. Okay, this is the H, and P is acting outwards. So your centrifugal force would be P is P into H. Okay, that is the moment is P into H. Basically moment is force into perpendicular distance, so H is the perpendicular distance, so your centrifugal moment would be P into H. Now P into H, now this is resisted by the restoring moment due to the weight of the vehicle W. Okay, now weight of the vehicle W is acting downwards. Okay, so this is the weight of the vehicle. Now this weight of the vehicle is W is equal to W into perpendicular distance. So basically we are taking moment at in respect of that B. Okay, so center to center distance is, it is B by 2. If total base is, that is the wheel base, it is B. In that case that half distance is B by 2. So your moment, resisting moment due to the weight of the vehicle is W into B by 2. So this means that there is a danger of overturning when the centrifugal ratio E by W is equal to B by 2H. Okay, so the equilibrium condition or the equilibrium condition for overturning will occur when P into H is equal to W into B by 2, or when P by W equal to B by 2H. This means that there is danger of overturning when your centrifugal ratio P by W, or centrifugal ratio as per the previous one, that is V square by GR, attains a value of B by 2H. Okay, now let's discuss about the transverse skidding effect. So the second tendency is transverse skidding effect. So how it is occurs, let us discuss. The centrifugal force developed has also the tendency to push the vehicle outwards in the transverse direction. Now if the centrifugal force P developed exceeds the maximum possible transverse skid resistance due to the friction, the vehicle will start skidding in the transverse direction. Now for this, refer to the figure. So whenever a vehicle is negotiating a curve, in that case centrifugal force P will acting upon this thing outwards. Now one thing that will counteract that that overturning effect is the weight of the vehicle. Now the centrifugal force may act also as enable the vehicle in skidding in this direction. Okay, skidding in the direction of the P. Now this skidding will counteract by the frictional force developed between the tires and the road surface. Okay, this is the tires and the road surface. Now consider this figure. Here the frictional forces are FA at tire A and FB at tire B. Now if the reactions are RA and RB, then it can be divided at F, small f, that is the coefficient of friction, into RA, and coefficient of friction into RB. So your the equilibrium condition for the transverse skid resistance developed is given by P equal to Fa plus Fb. So this is the equilibrium condition actually. So if you divide this, in that case F into Ra plus Rb, or Ra plus Rb is, it is W. Okay, basically Ra plus Rb is nothing but the W, so it is F by W. So for the transverse skidding to be acted, it is P equal to, equilibrium condition is P equal to F into W. Now the centrifugal ratio is P by W, it is equal to F. Okay, P by W is equal to F. In other words, when the centrifugal ratio attains a value equal to coefficient of lateral friction, there is a danger of lateral skidding. Okay, so so thus to avoid overturning and lateral skidding on a horizontal curve, the centrifugal ratio should always be less than B by 2H and also less than F.